Welcome everyone to this week's video. Today we are on Fish Friday number 210 and we have a good one for you today. This is actually more of a special Fish Friday video, which I'm sure you can guess by the title of the video. Essentially this was kind of a celebration of 4 years of doing Fish Friday. It's actually a little longer. I should have realized at 208, that's 4 years, but technically 207 was our 4-year anniversary of posting Fish Fridays, because remember, in all my entire time missing Fish Fridays, I have only ever missed 1 week. I have posted late, definitely, but missing in an actual week, 1 time, and I'm still going strong even with this new job, which is why I am doing my best and recording. If you watch Fish Friday of last week, you will realize that I am doing it the same day, but that is to be prepared for you all to provide the best videos that I can. So today's Fish Friday that we're going to be talking about is about taxonomy. Taxonomy. What is taxonomy? Well, taxonomy is the system we use, and I say we, the scientific community, but it's, the world uses to give scientific names to organisms. And it's actually very important to know that scientific names are actually descriptive. But scientific names in and of themselves are not just descriptive. All of their classifications have some sort of description into them. Now, the major taxonomic ranks are going to be life, domain, kingdom, phylum, class, order, family, genus, then down to species. Now, I've said this before, there's the specific epithet. A scientific name, a species scientific name, is comprised of the genus and then the specific epithet. And the genus and specific epithet together is what makes the scientific name, the species name. So, Vulpes vulpes, the red fox. Vulpes is the genus. Then the second Vulpes is a specific epithet. The species name is Vulpes vulpes, and that's very important. And it does happen for plants as well. Retibita calimniflora is the Mexican hat, or one of the coneflower species. Retibita is the genus. Calimniflora is the specific epithet. And I wanted to calimnifera. And I wanted to show this and talked about how the scientific name is descriptive. Look at this. Calimnifera. Calimnifera. Calimna, fera, flower, column flower. So each time you look at a scientific name, try and say, hey, what does this sound like? What does this mean? Because it's descriptive. It's descriptive. Remember that. And so just be aware when you're thinking about that. Now, every rank becomes smaller and smaller. That's what it's classified. It goes from very large groups, then we classify them down into more specific groups that get smaller and smaller. So, life versus no life. So something alive versus something not alive. I'm talking about, like, basically plants, animals, insects, bacteria, blah 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 blah, all this other stuff, and then rocks. That's like up there, but that's the separation. Then you have the domain. I should actually say, each rank of these has unique names. They're unique. So we'll think of it like the class Chondrichthyes. There's no duplication in the class level ever. So class Chondrichthyes is only class Chondrichthyes, and there's not another class Chondrichthyes that's over here. Genus is the same way. So the genus Oreochromis, the blue tilapia that we did before there is no other genus Oreochromis in the world that allows it to, be unique. It allows scientists to know what they're talking about. Specific epithets can be reused. There could be a lot of reuse of like specific epithet, like the Vulpes vulpes. There can be other Vulpes specific epithets out there, but the genus and this genus and the species specific epithet combined to a scientific name still makes a unique characteristics. And the reason for this was just to we'll get into a little bit more of the reasoning for this, but it's so that scientists can identify unique there. But each rank is actually grouping similar organisms, and you probably heard about this in high school, but I wanted to go over this a little more. So we're going to start at kingdom. Kingdom. What is a kingdom? The similar organism. Kingdom is basically separating all the animals from all the plants, from Animalia to Plantae. Then you have the phylum. Phylum Chordata versus like phylum Mollusca. Your mollusk and your chordates are going to be your animals that have basically a notochord or a vertebra, things like that. Then you go to like class. We'll go Chondrichthyes, which is the cartilaginous fish. And that's very important. So really a lot of people sort of start, or at least I do, I look at class. What's the class? Basically, the class is Chondrichthyes, the cartilaginous fish, meaning that all fish in this class are cartilaginous, meaning they have cartilage for skeletons. Order, Lamniformes. We're going down. Lamniformes is the family of white sharks. Okay, mackerel sharks. The mackerel sharks, okay, I know how mackerel sharks basically are. So all of the mackerel sharks in the world is in that order, Lamniformes. But it separates out those mackerel sharks from all of the Chondrichthyes, the skates, the rays, and the sharks. Then you go to family Lamnidae, which is the family of white sharks. Okay, now we're getting more specific. Going with white sharks now, Lamnidae. Lamnidae is the family of white sharks. They are usually larger, predatory, highly predatory, heavily serrated edged teeth, yada yada. So each one is becoming more specific and getting smaller and smaller. Genus Carcharodon, which is the genus of white sharks. Okay, well now we only got like 10 to 12 species we're working at. I think it's more than that. But now we're getting very, very specific. Okay, what makes Carcharodon? Then the specific epithet is Carcharis, and that gives us Carcharodon carcharius, which is the great white shark. Carcharodon carcharius. Now, you can even see here's the scientific classification. It's going to have your domain, Eukaryota, basically multi-celled organisms. Animalia, boom. Chordata, family of vertebrates. Chondrichthyes, the cartilaginous fish. There are other ones, subclass, subdivision, subfamilies. Like there's a lot of extra in there, but those are the major ones. But you can see here, order, Lamniformes, family, Lamnidae, genus Carcharodon. And it's actually important to note that class, order, and family is always going to, in fish, is always going to have the same, oh, I can't remember the exact term for it. The last 4 at the end of the word. So chondrichthyes, osteichthyes. That's basically the 2 fish. I think there's one more, but chondrichthyes and osteichthyes. Cartilaginous fish, bony fish. Then the order, lamniformes. Oh my goodness, I'm drawing a blank on all the rest of them. There's a lot of them out there. Oh my god, just think of one, Ping. Just one. I can't. I spend most of my time at the family level, so. But anyway, so lamniformes, all the other orders of fish are going to have iformes. That's, or at least formes at the end of the name. And that allows, if you're talking with an actual taxonomist or someone who's not just going loopy in the head, if you say the order name of a fish to a scientist, they may not know that order, but they're going to hear that formes and they're going to be like, okay, it's an order of fish, so we're probably talking about a more basic classification. Same with the family Idae, or D, and it's not day, it's actually Lamnidae. But if you say that, a scientist immediately knows, okay, we're talking about a family level of fish, not an actual fish species. We're talking about a family level. It allows things to be much more consistent and allow things to know. Now, there is no sort of like guidelines for genus or species, and most of the time, the specific epithet is usually named after a famous scientist there. But I just wanted to give sort of a background on the taxonomy of things. And let's actually kind of do a tiny bit of history. We're going to do it super, super quick. So taxonomy actually began with Aristotle, and he primarily did animals, and he separated animals by basics. Lived in water, didn't live in water. That's how he just classified things. And it was not accurate, but it was a start. And, you know, it's how scientists actually classify things. His student, Theophrastus, actually was the one who did most of the work on plants. Aristotle probably did some work on plants, but Theophrastus is actually considered the father of botany. He did a lot of work with plants, and I believe he actually created the first botanical garden. After Theophrastus, basically very little work was done until the 16th or 17th century in terms of taxonomic classification. Then, in that time, there was a ton of plant work and plant taxonomy done that was primarily done by physicians that were looking for new plants that were getting discovered in Africa and Asia and everything like that. And new plants that would get discovered, they'd look at medicinal properties, and other people would look at different things. And that created a lot of problems until the father of taxonomy, Carolus Linnaeus. Carolus Linnaeus was actually a very, very important one, and he is known as the father of taxonomy. He was actually very much into botany and was considered a very young botanist. However, he hated the fact that there were so many inconsistent systems. The same plant would have very different scientific names because this person classified it like this because, okay, let's take like like a plant that produces a pain relieving effect. This person over here, who was a physician, grouped all of the plants that had pain relieving effects into one group. Whereas this person grouped all the plants into, it had a rough bark. So it would split this and it'd have scientific names for the same plant that would have so many different scientific names depending on who did it. It was an exhausting and it was inconsistent to the point that the person who created the system could use it. But Carolus Linnaeus was like, well, how do I communicate so that this plant that I named, you know exactly which I'm talking about? So he started creating a new system, and he actually grouped plants based on the structure of the flower parts, such as like the number of stamens in the flower. And he was the first person to use binomial nomenclature consistently. He wasn't the first person to do binomial nomenclature, but he was the first to do it consistently. Now, his system was not accurate, but it was easy to use and it was easily adopted. In fact, he even Linnaeus even classified minerals this way. And so it allowed for this sort of system to be developed, and it's evolved over time into what it is today. And it's such a good system. A lot of people don't understand it. It's not, the scientific name of an organism is not just something that's thrown about willy-nilly. Like, there is so much that actually goes into that, because you have to classify it from the top down. And that is why it's so important. When I was in college and I was helping teach other students, you can't just look at a fish and immediately know what it is. And I try and talk about that in the videos, at least somewhat, is what makes a fish a fish? Well, you look broad first. What is the family? The family of, cichlids. What do all the cichlids have in common? So when I look at a fish, and I may not be able to know immediately what species, but I was like, okay, based on this and this and this, it's a cichlid. Okay, well now I've separated all from there, and then I only need to look at the rest of them. And then I'm like, okay, well, what's genus am I looking at? And then you start devolving down and going on and on. So because everything's been, it's been grouped together, it helps you know what you're looking at so much easier. Think Micropterus, the largemouth bass, Micropterus salmoides. You come down, Centrarchidae, it's a family of sunfish. Okay, well, the sunfish has this. Okay, boom, I know I'm looking at a Micropterus based on X, Y, and Z. Okay, well, when I group it up into Micropterus, I know I'm only looking at like 5 or 6 fish, and then we can go to really key differences. So you have to work from the top down. It's very important. Very important. But anyway, thank you guys so much again. I really appreciate it. I hope to see you again. Please leave a like, comment, and subscribe. If you do, I'd really appreciate it. Hope to see you again. I hope you enjoyed this video, and I hope it's just a nice refresher for a lot of people. I actually love taxonomy. Not enough to be a taxonomist. There are people that actually their jobs out there are to help people classify newly discovered organisms. I love taxonomy. That is not my thing. Those people, they have so much more knowledge than I do. But I really hope you enjoyed this video, because I definitely enjoyed making it, and I thought it needed to be made. But take care of yourselves, take care of your loved ones, and peace.